Scalar multiplication of a vector. Consider vector A equals A sub x A hat sub x plus A sub y A hat sub y plus A sub z A hat sub z. Multiplying vector A by a real scalar m, which can be positive or negative, m distributes across the magnitude of each component along its unit vector direction. Another essential operation is the dot product, denoted by dot between two vectors. Suppose vector A and B are defined as this. Now, evaluating the dot product A dot B term by term. First term of A dot first term of B equals A sub x B sub x A hat sub x dot A hat sub x, which can be obtained by this equation. Therefore, it equals A sub x B sub x. Now, A sub x A hat sub x dot B sub y A hat sub y, since these two vectors are orthogonal, it becomes 0, and so is the first term dot the third term. Now, the second term of A dot the first term of B is also 0. The second term of A dot the second term of B, A sub y A hat sub y dot B sub y A hat sub y. So it equal to A sub y B sub y. And the second term of A dot the third term of B equals 0, because they are orthogonal. And now the third term of A dot the first term of B is 0. The third term of A dot the second term of B also 0. Finally, the third term of A dot the third term of B equals A sub z times B sub z. Now, by summing the results, A dot B equals A sub x B sub x plus A sub y B sub y plus A sub z B sub z. And this is the result of dot product between two vectors in the rectangular coordinate system. Example: what is the magnitude of the projection of vector A onto vector B? Vector A equals 2A hat sub x plus A hat sub y. Vector B equals A hat sub x minus A hat sub y plus the square root of 2 A hat sub z. The scalar projection length of vector A onto vector B is defined by vector decomposition as projection equals the magnitude of vector A times cosine of alpha, where alpha is the angle between A and B. From the definition of the dot product, A dot B equals magnitude of A times magnitude of B times cosine of alpha. Solving for cosine of alpha equals the fraction A dot B over the magnitude of A times the magnitude of B. Substituting cosine alpha back into the projection formula, projection equals A dot B over the magnitude of B. Evaluating the dot product, A dot B equals 2 times 1 plus 1 times negative 1 plus 0 times the square root of 2, which equals 2 minus 1 plus 0, which equals 1. Calculating the magnitude of b, the magnitude of vector b equals the square root of 1 squared plus negative 1 squared plus the square root of 2 squared, which equals the square root of 1 plus 2, which equals the square root of 4, which equals 2. Thus the projection length of A into B equals 1/2. Properties of the vector dot product. Self dot product. When a vector A undergoes a dot product with itself, A dot A equals magnitude of A times magnitude of A times cosine of 0 degrees, which equals the magnitude of A squared. Distributive property. Given three vectors A, B, and C, evaluating A dot open parenthesis B plus C close parenthesis. Okay, it equals to this equals to A sub x B sub x plus A sub y B sub y plus A sub z B sub z plus A sub x C sub x plus A sub y C sub y plus A sub z C sub z. Now the first parenthesis is actually A dot B, and the second is actually A dot C. So A dot open parenthesis B plus C close parenthesis equals A dot B plus A dot C. This confirms that the dot product is distributive over vector addition.